All right. So there's the official announcement for everyone. We're now being recorded. So if something doesn't work out, or if we say something too stupid, it's going to be there forever and ever and ever. With that said, yeah, with the first assignment, using the pivot tables, you basically get to do some of the stuff that we were talking about in the first class. I've tried to figure out like what's a better assignment to do for that. And with with everything, literally what I'm trying to do is get you guys used to using Excel. So there's um it's a little bit more than you might be used to. It's going to be something new and scary, and I totally know that. You're not the only one that's struggling with it, and you're not the only one who will ever struggle with it. So there is a lot uh, to like try to take in, but being able to use Excel is going to be something that is highly beneficial to everyone, even if you say get out of this class and you're like, you know what, if I have to do that all the time, I never want to touch another like public health or do anything in health sciences ever again. Yeah. I could, this is the type of thing where you could be a bar manager and being able to use this stuff is actually going to be quite useful. So it is intimidating and you're working with a huge data set. And then you also have to remember that everyone in that data set is someone basically that was just like you. They're undergrad students. They're people who students like yourselves. Some of them might be younger, some of them might be older, some of them might not be that good in mathematics or whatever else. They're going into all their classes scared, hoping that they do well, and just trying to put some like a human touch to all of this stuff. Because when you look at everything and you realize, uh, like quite literally, that some of the professors that I've actually seen, and I gave a like a 20-minute talk to one of my classes earlier today. There were some professors that taught math classes, uh, where 20% of their students passed. They've taught 700 of them. There are other professors in that teaching that same course. So like say Algebra 2, they've taught 500 students and 80%, 90% of their students pass. So being able to look at it, being able to break everything down, uh, and just something to think about too. Say you do get into working in uh, at like a hospital or something like that. If you have information on, say, who, like, who is the main doctor for a surgery, who were, say, the nurses, who were the assistants, and all that sort of stuff, and then you can make a little mark to see, like, post-op infections or something like that. Did they get a post-op infection? You put a one. If they didn't, you put a zero. And then you can go through and do basically the same thing you're doing here and look at potential issues because you might find that, say, a particular doctor uh, that everyone might think is really, really great, but 5% of their patients have post-op infections, whereas some other doctor might have 0.2%. So being able to look through everything, that's the key here, using some of the ideas we had initially, that's the other key. You're all going to struggle. You're all going to have some issues. And quite honestly, I didn't even know how to do this stuff until like 2 years ago when uh, I someone basically looked at me and went, "Dude, you just spent how much on that software? You could have done that in Excel. Let me show you." I'm like, "Mm." So because I didn't know about it, I had to take a literally $200 of money I could have spent on important things, like beer and food, and had to buy software with it. So, yeah, it is intimidating, but If the worst comes to worst and you're not able to get any of it done, for whatever reason, it's 15 points out of 1,000. It's not like you're instantly going to fail. If you need some extra time, after we're done tonight to work on it a little bit more, I'm totally fine with that. Uh, I'm if you talk with my former students, they're going to tell you, yeah, he wants everything due on Wednesday, and then he might check it within the next week and a half, which is true. So I'm not going to be much of a stickler for getting it in on time. If you're turning it in a month and a half late, is that going to be an issue? Yeah. You turn it in, say on Friday or Saturday instead of today. And for the people that are going to watch this later, turn it in on Saturday instead of uh, on Wednesday. I'm I'm not going to mark you down for that because uh, I'm not going to get to it until the weekend, probably next week, anyways. And
So,
I see Audrey's had her virtual hand up for a while. So, what's up?
thank you. I actually did have a question on that. I was
Sure.
wondering if it might, I just want to make sure that I analyzed using the right data set. If it's possible to use a quick screen share as an example,
Um,
or
if you want,
um,
well, if it's set up for a screen share, so if anyone is having issues with like getting the videos to work or anything like that, at the break, we can try to figure out what's going on.
yeah,
Uh, but let me, so if you're using the data,
yeah.
so
So
I,
I sorted it by course, and then I sorted it. The population that I basic or the sample size I picked from was same year, same course, same semester. But I didn't know if we were supposed to do everybody who's taken that course for all years and all semesters.
yeah, in order to get, so a way to think about this, and since you said you're getting into the physical therapy program, um, you need to look at the say everyone that's been in there. Some of the things you're going to find are certain professors have a much higher pass rate than other professors. You're going to find that some professors are just 30%, 40% of their students pass no matter what class it is. Some of them, and I was showing my students this earlier today, you take their class and say Algebra 1, you might get it 80% of their students will pass. You take them for Calc 1, 40% of their students are going to pass, which is kind of the opposite of, say, other professors where you take them for Calc 1, you're almost guaranteed to pass, but you take them for Algebra 1, they're going to be extremely hard on you. So, uh, and the way that you do it, I'm trying to see if I've got the data on my desktop, and of course I don't, because that would be way too freaking convenient for me. So if we're looking at the OU student data,
So you
and
and so like for example, if we were to look at Chem Chem 1, which I think is the CHM, we would look at all the years that it's been like every single time it's listed, not just we wouldn't try to isolate it
yeah,
because we want to see how many
right,
across all the
because
years, how many people.
right, because one of the things that can actually happen, uh, if you look at it year by year, and let's say you're looking at a professor, say the first year that they taught it, uh, I don't know if I'm allowed, should be this honest, especially if everything's going to be recorded. But some of the things happen when, say, I'm starting teaching in classes at a new university or something like that. Uh, Honestly, most of the times the department heads that I'm talking with talk up their students and they're like, oh, my students can do this and that and blah, 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 blah. So if I go into a class thinking all the students are up here and I start teaching up here, I'm going to scare a lot of them away because, and nothing personal to anyone, but most of the students are actually down here. So first semester, you're going to be over teaching over everyone's head and then wondering what's wrong with everyone. And then realize, oh yeah, the department head lied their butt off. The students are actually down here. So let's come in with this expectation and then try to raise them up. So looking at it year by year, things like that can happen. There could be a particular section where it's just a bunch of, say, really bad students. Like last semester, so like winter semester for us, I was teaching two sections of the same class. One of them started at 8:30 in the morning. The other one was at 10:30 in the morning. The best student in my 8:30 class would have been average in my 10:30 class. So because of stuff like that, we want to look at everyone. We want to have the best idea of how everyone is doing. And if you look at what I've got here now, I just clicked in the corner, highlighted everything. Now I'm going to do the insert, the pivot table, click on OK. And then I'm going to say, I want to look at pass. And because I want the average and the count, bring these down, go to sum of pass, value field. This is going to be average. Click on here, the value field. This is going to be count. So now I've got what's on the screen right now. Make it a little bit bigger so you can see it. And then I know some of you were grabbing course and bringing it down here. One of the things that happened at Oakland University, which is really annoying, is like, oops, these two classes right here are literally the same thing. It's just that one of these classes was, say, taught in 2009, and then in 2010, it got this new designation, which has four numbers in the course title instead of three. But it's the exact same class. So if you did it like that, I'm not going to worry about it. Don't go back and redo it. But if you are trying to deal with it, uh, a much better idea would be to use course name. That way you now have all of the Algebra 1 students. So like all the uh it used to be 062 and then it's 006 or 0662 or whatever it is. They're all included in here. All the old all the students that took the Algebra 2 are in here. All the students that took astronomy are in here. Okay. Once you've got that, if we want to see how well the students do based on instructor, we can now see all these different professors. And just looking at like Professor 65 here, 334, in this case, total student records, and 36% of their students pass. And then you look at this other professor here, Professor 85, again, 220 total student records, and 77% of their students pass. Between 65 and 85, who would you rather have as your professor, as an example, if you're looking at Algebra 1? Professor that passes 36% of their students or 77% of their students? That should be a no-brainer, right? And then these are total student records. I'll get to you in a moment, Audrey. Uh, so the next thing, there should be this thing here that says attempt. If I put this down at the bottom, what it's doing now is it's breaking everything up based on the order of these things. So I can now look at this and I can say professor number 20, overall, their students passed 91.7% of the time. But they only had 12 students. That's only one section. From statistical point of view, even though that professor looks really good, there's not much there that we can look at. So we might have to scroll down to, say, this professor, 65, and you can see that students that are taking class with them the first time, only 35% of them pass. Of the 32 that retook the class with the same professor, 46, 47% of them passed. If we move this up, what we now have is for Professor 65. Each one of those students is one unique student record, and it's the first time they took the class. For a lot of math classes and for a lot of students, um, and I'm sure some of you may have had issues like this. Um, if you don't do well in a certain, say, required course, you're either going to think about changing majors, or you might even think about changing colleges or universities, or you might even think about, say, even dropping out of class or out of university. So I'm looking at this as you've got one chance to keep a student around. How do you do that? You have to make sure that the student does well enough. So that's where like all of this stuff comes from. So what's up, Audrey?
This is super helpful. The one question I had was I did this for the two, and maybe it's just misunderstanding the assignments. I did it for the two courses from question one of pick two courses that you're either interested in
Yeah,
taking. Okay, so
yeah.
we did, I
Everyone's
didn't know if we were supposed to do it for that or for every last one.
no, everyone. You've got. So if I get rid of instructor ID, if I get rid of attempt, you have the opportunity to look at Algebra 1, Algebra 2, Astronomy, Business Calc, Calc 1, Calc 2, Calc 3, Chemistry 1, or General Chemistry 1, General Chemistry 2, College Physics 1 and 2, Computational Chemistry, Differential Equations, Discrete Mathematics, Engineering Physics 1 and 2, Everyday Math, Everyday Physics, Finite Mathematics, Geology, Intro to Chemical Principles. For any of you that are in here right now that are, say, nursing students, that intro to chemical principles, and then the nursing chem are like the two, say, chemistry classes that you'd have to take if you want to get the BSN degree. So if you haven't had those yet, those might have be of interest to you. If you're more of a pre-med, perhaps Orgo 1 and Orgo 2 are more of interest to you, because those are two classes that are known to be like weeder classes allegedly. And you can take a look at how students did in those. And then physics lab, pre-calc, probability and stat. The stat for bio is essentially the class that you are all taking with me right now. It's made for students that are in pre-med, and say in pre-med in a generally in a more traditional pre-med program, like say biology, biochemistry, something like that. So you choose what classes you care about, and then you tell me what professor you wish you had, or if you knew who these professors were, who do you wish you had in all those classes? Does that make sense?
Yes.
All right. So any other questions?
I have a question. If we don't get, so like tonight, if we don't have enough time to like screen share, do, isn't your office hours tomorrow afternoon as well? If I read that correctly.
What?
Um,
Uh,
oh,
Go
sorry.
ahead.
Um, So I work until 5. Is there any way that we could, if like I had questions on another assignment and I didn't get to it today, during this Zoom, because I know we'll be talking about different topics, I'd assume as well, other than the homework, if we could meet during that to go over things, or what is your best scenario for us to do in that case?
Um, I can meet with you at different times. It's just a matter of where I would be meeting with you. Like,
Okay.
the office hours that I've got set up are like Tuesday, Thursday, 3:30 to 4:30. Those times are basically when I have to be in my office down at U of M Dearborn. So those are really convenient times for me to meet with, say, any of you. If you have questions, I'm teaching another stats class down there in the business school. It's like literally right after class for all those students. So if they have issues, they can come in as well. If that time doesn't work for you, I'm totally fine with that. Uh, like I was talking with Carmen and Verlin on, what was it, on Monday at 5:30. And I was talking with them from, say, my bedroom. Uh, on Tuesday, Thursday, in general, after my office hours are over, I'll go out and grab dinner wherever I happen to be at. Uh, and the places I go to, they've got Wi-Fi, so I have no problem, like, say, pulling this up and working with you if you do have questions. But keep in mind, while you're asking me questions, I'm going to be sitting there eating and drinking. So usually the background noise isn't that bad, but uh, we can meet pretty much any time. So if you need different times than we have, feel free to ask. The worst thing I can say is I can't meet you at that time, and but maybe we can meet an hour later. Maybe we can meet uh half hour later or something like that. Okay.
Thank you. So I'll just send you an email after class, and then just to triple make clear, our assignment is not going to be considered late if okay, perfect, awesome. So I'll send you an email and shoot, maybe we can work. I'll send you an email after class today. Thank you. I
Um,
appreciate it. I appreciate how flexible you are. You seem to be a very dedicated student or dedicated teacher to your students. We appreciate that.
yeah. Yeah, like I was saying earlier, I'm not going to be grading these things tonight anyways. I'm not going to be grading them tomorrow. And one of the reasons why I give you all 2 weeks to get this stuff in is because I know there are going to be issues. Like if literally if I was to go through my emails just from from this class, I think I got 5 or 6 of them today from students that are still having issues actually getting access to the videos, which means I'll probably have to take all the class videos, download them onto my computer, then upload them into YouTube, uh, which means they will be made available for everyone. I will send a link to everyone so you can see all the videos, and hopefully you can just use YouTube as opposed to trying to log into Canvas, go through the 2-factor, 3-factor authentication, blah, 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 whatever. Because personally, I couldn't care less who watches these videos. Uh, some of the videos I've done this before, and I'll have like comments uh, checked off so you can't leave a comment. So if someone watches is like, oh, you're a moron, blah, blah, they'll have to figure out how to email that directly to me instead of, say, being anonymous type of thing. But I've got no problem with that. Uh, And again, part of the reason it's 2 weeks is there will be some kinks if we need to work things out. Uh, exams, those need to be turned in on time. Final exam definitely needs to be turned in on time because I literally have uh like 2 days after the final to get your final grade in. So if you turn in the final exam, say 3 days late, or if you turn in something for the final, and I actually had this happen to me when I was teaching here before. Student turned in a final or something for the final, but they turned in the wrong exam. They turned in exam number 2 instead of the final. And at the time, U of M Flint was going from whatever server it was to a different server. So if you wanted to receive an email, or sorry, if you wanted to send an email, that wasn't an issue. But if you wanted to receive an email, you actually had to go and log back in. With this particular student, she was freaking out. It's her final exam. She doesn't have a grade, and it's getting closer and closer to when grades are due. She's wondering what's wrong. I'm replying to every single thing, but nothing is going through. I asked one of the administrative assistants to contact the students, tell them to check out their email, told the administrative assistant what was going on. She actually told the like the dean. Uh, so I went in. Eventually, everything worked out. I graded her final, got it in on time, and then the dean found out, went in and actually changed that student's grade from like a, say a B minus, which she deserved, to an F because she didn't turn in the final. And then he reprimanded me for not following the department protocol. So some of this stuff, it is serious when you get it in. Some of the stuff like the homework, if it's a day or two late, I don't care. If it's months late, yes, that is an issue. I'll taught another place, one of the students failed the class and then asked why. I told them, well, you didn't turn in any of the homework. He turned in all the homework a week or the week between Christmas and New Year. It's like 2 weeks after final grades were due. I refused to grade his stuff. He went to my department head there, complained. My department head then reprimanded me for not grading the student's homework. I showed the department head, hey, he turned it all in between Christmas and New Year. Here's what he turned in during the semester. It was all zeros, all blank. And she went in and changed the student's grade so that they passed instead of failed. And then I didn't work there again. So some of the things you learn the hard way. But anyway, since I have all of you here, and for the students that are doing this at home right now, if you want to go ahead and open up the exam 1 calculator, if you don't have it downloaded onto your computer, uh, you should be able to go to our Canvas site. It is one of the few files that's actually on there. We will be using that tonight. And specifically, we will be using the binomial distribution and the Poisson distribution tonight. We will also be using in the second half of class, if I can get this to come down a little bit. Stupid controls for a zoomer at the top right now, so anything that opens up too high can barely grab it. We're also going to be using the multiple file. I believe I put that on our Canvas site. If I did, awesome. If not, let me know. I will put it on there. But tonight, we're going to be talking about the binomial distribution and the Poisson distribution. They are two, when we talk about probabilities, both of these things are highly useful for different purposes. And the information that we can get from these is going to be quite a bit different from, say, the information that we would get from a typical, say, normal distribution. So let me grab my pad of paper. And we'll start writing some of these things down. And hopefully the camera that I have, it will actually work properly. So I'm going to stop the share real quick. I'm going to flip over the camera. That is a very clear photo, isn't it? Let me. All right, so that's looking a bit better. Somehow I got this camera to work really well when I was using it at home. Not so much uh, this semester. I don't know, maybe my camera doesn't like being traveling to Flint or something, would prefer to stick at my house all the time. But anyway. We've got the binomial and the Poisson distributions. With both of these, they deal with integer values. So basically, if you're thinking 0, 1, 2, 3, 4, 5, 6, numbers like that. Let's see. So Abby, you asked where can I find this? Are you talking about the exam one calculator?
No, I have the exam one calculator pulled up, but I can't find the exponential thing.
Oh,
Or not
the multiple?
the
Well,
what? Sorry.
sorry. So you're looking on here. So when I first opened this up, just for I have no idea why it behaves like that, but it's gonna look it's gonna look kind of like this, right? If you look over here and look, sorry about that. Need to share the screen so that you can actually see what I'm pointing at.
Yeah.
All
I was like, I can't see it.
right. So when you open it up initially, it's going to look like this. And
Oh,
then
it's at
you've
the
got
bottom.
these three dots over here, and then there are these arrows.
Yep.
So I just have to keep mashing the arrow until you can get to the binomial distribution or the Poisson
Oh,
distribution.
okay. Got it.
All
Thank
right.
you.
So it is on there. I think I was talking with the Verlin on Monday. If you have a graphing calculator, you can use it on the exams. If you don't have a graphing calculator, do not go out and buy one for this class. You can use the Excel spreadsheet, and I'll show you how to use it. And we will do everything we need to on there. So getting back to all of this stuff. Both of these deal with integers. If we're talking about the range of values that we can have here, binomial distribution goes from 0 to some maximum value. Poisson goes from 0 to essentially positive infinity. So I will say when it comes time for exams, when it comes time for, see if I can get the whole thing on here. When it comes, oops, sorry, my gooseneck isn't goosing as well as it used to. Part of what's going to be on you to figure out or you to reason with is what distribution am I using? So you're going to have to think about this a little bit, but essentially for dealing with the binomial, goes from 0 to some maximum. Where do you, and everything has to be done in integers. So way of thinking about this is where do you have a maximum number of points? So if we're talking about, say, quizzes, tests, exams, you can get anywhere from, say, 0 points up to, say, 200 points on the exams in the class. If you have another professor that gives you, um, say, 20-point quizzes or something like that, again, that those or you've got 20 points max. So that's where this idea of a max comes in. If we're talking about Poisson, we're talking about integers, and essentially we're trying to discuss here uh, things that can go from 0 to infinity or 0 to a really large number, and there is essentially no upper bound. So for example, if we want to talk about, say, the number of hours that you work, say, in a year for whatever company it is there a maximum number of hours you can actually work? Or is the maximum number of hours, or are the hours that you get to work, wherever it happens to be, say, uh, you can work as much as you want or as much as your boss will allow you to, type of thing. Another place where this comes in, it would be, say, in sports. So if we're talking about, say, baseball and, say, hockey, where you score points basically one at a time. That would be a really good use of the Poisson distribution. If you're more of a basketball fan, because you can score points based on 1 point, 2 points, or 3 points, so a free throw, a normal shot, and a 3-point shot, Poisson is still useful, but instead of looking at the number of points you made, we'd be looking at, say, the number of free throws you made, or free throws you attempted. We'll look at the number of 2-point shots that you take, the number of 3-point shots that you take, or 3-pointers that you make, so you actually score something. So that gives us an idea about where some of these things can be used. If we're talking about, say, the average and the standard deviation with these, uh, the average, I talked about it a little bit on the first day, and I said when we talk about average, we can say the average, we can say the mean, or we can say the expected outcome. So in this case, it would be E of X equals, and then summation thing here, N times P of X. What is this N? What is this P of X? N is, say, the number of opportunities uh, that you have. So if this is, say, a 200-point exam, N would be those 200 points, and P of X would be probability that you get any of these points. The formula for standard deviation, if you look it up in the textbook or if you look it up elsewhere, it is a complicated formula, and that's actually going to be calculated by some of the software that we're going to be using. So you don't need to worry about that too much. But if we're talking about the mean for the Poisson distribution, it's given as a funny looking wishbone thing that we call it lambda. Then the standard deviation is basically just the square root of lambda. Another place where the Poisson distribution is used a lot, and we're actually going to be using it a bit the second part of class, is if we're looking at rate or various rates. So if we're talking about, say, since I know a lot of you are looking to get into um, like various parts of the medical field, we can look at, say, if you're in the respiratory therapy, program, just as an example. There might be, say, three techs or two or three techs that happen to be working at a hospital or happen to be working in, say, the ER of the hospital or something like that. And then we can look at the number of people that enter the ER who have respiratory ailments where you would be called upon and you'd be a valuable part of, say, the diagnostics team type of thing. For those of you that may not be working in a hospital or any place like it right now, trying to talk about that stuff can be really difficult, uh, especially if you're not familiar with anything that actually goes on in the hospital. So another place where we could look at that, which everyone here has experienced, we can think about that as, say, cashiers at a whatever your favorite grocery store is, or cashiers at your least favorite grocery store, depending on how you want to look at it. How many people enter the grocery store at given times? How quickly can the grocery store say check people out once they're ready to do that? And we're actually going to look at that the second part of today. The web extra that I recorded it yesterday and just made it accessible to all of you. Uh, Gets into that a lot more detail than we will have time for tonight. So that's going to be something that we can look at. With the binomial distribution, we'll look at this two different ways, and we will also have a little bit of discussion about something called risk. If you've had a lot of public health classes already, you may be familiar or you may have done something with the risk analysis, or you may heard of the term, what are the risks of this, that, and the other. If you have, this is the same basic idea, but we're going to be looking at it in terms of, say, data that we have, and we'll try to make decisions based upon what are the various risks of this happening versus that happening type of thing. Okay. So it may not be exactly 100% applicable as far as the examples go to, say, your working life, but at least when it comes to, say, your, sorry, I'm trying to, well, weird stuff is happening on my side with Zoom right now. My apologies for that. So anyway, but having an understanding of how you can look at the risks and try to deal with them, try to come to some sort of a conclusion based on everything, that's going to be a big part of what we talk about uh, pretty much throughout the whole rest of the class. Okay. And sometimes dealing with these things can become a bit awkward. Uh, but uh, it it's just something that we're all gonna have to eventually work through. All right. So to start us off with the binomial and to keep it in dealing with things that all of you will at least be somewhat familiar with, let's say we're dealing with a with an exam or with a quiz. Sorry, quiz versus exam. Okay. And what we're going to do here is we're going to look at what is the probability that, say, you get an A on a quiz versus an A on an exam, and then the probability that you get a B on the quiz versus a B on the exam, C on the quiz, C on the exam. And then just to make it easy, I'm just going to assume that it's either an A, a B, a C, or you didn't do very well, just to make it a little bit easier. Some of these, or in the way that we have to look at these two, it is a bit tricky. The nice thing is with the binomial distribution and the Poisson distribution, the way that we have to look at these things is actually fairly similar. Or the way that we look at these things, the way we have to understand these things is fairly similar. Unfortunately, when we get to the material next week, pretty much everything that I tell you today does not apply to next week. And the stuff that happens next week kind of doesn't apply to what we're talking about this week. It's going to be confusing. But hopefully we can understand the types of things that are going on and try to get a hold or grip on why we're doing things the way that we are. So if you do have your that exam one Excel sheet open, if it's open to the binomial distribution, that will make things go quite a bit smoother. I'm going to change my camera again. So, and I know that this is going to look a bit weird. It's going to take a little bit of getting used to. Let's say we're looking at A, B, and C range. We're going to be dealing with these based on a quiz and an exam. And then out here, I'm going to say what are the percentages that we're looking at. So if we're looking at an A, at least in my class, you have to get between a 90% and a 100%. For the B, it's going to be 80%. If we're looking at, say, the total number of points we have at the end of the semester, 89.9%. If we're looking at a C, that's going to go from 70% to 79.9%. That's kind of going off the screen, isn't it? Sorry about that. And then if you do bad, it's basically going to be from 0% to 69.9% overall, okay? Now with the quiz, I'm going to assume that it's out of 20 points. With the exam, I'm going to assume that it's out of 200 points. So the N that I put down here, that's the N for the quiz. That's going to be the N for the exam. And if we're looking at the number of points that we need here, so if I need 90% of 20, I can have 18 points to 20 points. So this is going to be 18, 19, and 20. For the quiz, this is going to be 16 or 17 points. This is going to be 14 or 15 points. And then if we do bad, basically 0 to 13 points. And if you want to try to think about where does all this stuff come from, what is 0.9 times 20? It's 18. What is 0.8 times 20? Well, that's going to be 16. What is 0.7 times 20? That's going to be the 14. What is 0% times 20? That's going to be 0. So we can figure out what all these low values are going to be here fairly easily. The high values are basically, if you look here, we've got 14, and then we've got 16 up here. What's the next possible number or highest point to 16? It's going to be 15. If we're looking at the 200-point exam, that's actually going to be 180 points to 200 points, 160 points to 179 points. So again, where does 160 come from? 80% times 200. So there we go. 140 to 159 points. And then for this last one, 0 to 139 points. Okay. Does all that make sense so far? You can just put a thumbs up on the screen if you need to. Right. I got a couple. Okay. So here's where things get really weird. I'm going to look at these two on a different page. And there are a couple different ways that we can actually try to calculate these. So using some of the terminology, using some of the ideas from statistics, I can say the probability that you get an A on the quiz is going to be the probability that you get 18 points plus the probability that you get 19 points plus the probability that you get 20 points. The probability that you get a B is going to be the probability that you get 16 points plus the probability that you get 17 points. Okay. Now we have to use the binomial calculator that I've got to actually figure these out. If I'm looking for individual values like these, and let's say, and just in case you have to go and talk with the tutor about these things, okay? They might not know how to use the Excel spreadsheet that I've given you, so they might try to use a graphing calculator. That is not a problem. If we are using the graphing calculator, and I will say as well, when you try to show me your work on the exams, this is basically how I expect you to show it. I know you're going to be using a calculator. I know that that's what's going to happen. But to show me what you put into the calculator, this is how I expect you to do it. Okay. So in the graphing calculator, there's something called a binomial PDF. And you can put in 18 plus binomial PDF of 19 plus binomial PDF of 20. Because I've only got the three numbers here, doing this out the way that I just showed you here is fairly easy to do. If I'm a different way of doing this would be to look at the binomial, what's called a CDF. And these are both different things that actually appear on your graphing calculator. I can pull mine up in a moment to show you what I'm talking about. And if you have the binomial thing already set up, I have it set up for PDF as well as CDF. So we do binomial CDF of 20 minus binomial CDF of 17. And that is, sorry if it's a little bit small, but that is a 17 at the end. So what we need, when we do the calculation, if we put this into the binomial CDF calculator, we will get the exact same values if we put these three things into a calculator. So just as an example of what's going on here, we've got probability that you get 20 points plus probability that you get 19 points plus the probability that you get 18 plus probability that you get 17 plus a probability that you get 16 plus probability that you get 15 plus the probability that you get everything else all the way down to 0. The binomial CDF adds all of these things together. So the CDF is good if we're looking at a specific range of values. The PDF is if we want to look at a very specific value. So again, this is for a range of values. The PDF is if we want to look at an exact or a specific value. With the range of values that we're looking at here, the binomial CDF is all of these. What values do we actually want? We want the first 3. The binomial CDF of 17 is the probability of 17 plus the probability of 16 plus the probability of 15 plus everything else that's below it. So when we plug this in and say binomial CDF of 20, we get all these values minus the binomial CDF of 17. We have all of these values, everything on the top minus everything on the bottom will leave us with what we want. Like I said, for the problem that we have here, or are doing right here, right now, using the thing on the top, using the thing on the bottom does not matter. However, when we're looking at the range of 200 to 180, what would we have to do if we calculated every value by itself? Well, you'd have to look at the probability of 200 plus the probability of 199 plus 198 plus 197, 196, 195, 194, 193, 192, 191, 190, 189, 188, 187, 186, 185, 184, 183, 182, 181, and 180. And then add them all up. Versus using a similar idea to this, where you only have to put 2 things into the calculator. So let's take a look at the exam 1 calculator. So I'm going to share my screen. And hopefully you can all see that I have this on the binomial thing. Does everyone see that? So what we need here is we need to know essentially what is the probability that you are going to, say, get a single point or any particular point on the exam. So if you've taken, say, math classes before, and I know that you all have, I don't know what your average was on all those exams. For this, I'm just going to say there is a 82% chance that you get or your class or your average on the exams and quizzes in your last math class. I'm going to pretend that it's 82%. Is that high? Is that low? Honestly, at this point, I really don't care. We're going with 82. The N here, that's going to be the number of points that are on the quiz. And if you enable the content that's on here, if you notice the numbers that I've got on the screen actually keep changing. The numbers on your screen should also keep changing. So if we want to do the binomial CDF, again, the high value I'm looking at is 20. The low value, so the value I want to cut off, I want to cut everything that is 17 and below. So this is telling me that on this particular quiz, there is a 27 points, I'll call it 27.5% chance that you get an A. If I want to look at the probability, or if I want to look at all these things individually, I can come down here. So again, what is the probability that you're going to get any particular point on the exam? Again, I'm saying you average an 82% on your quizzes and exams. There are 20 points possible, and we want to look at what is the probability that you get exactly 20 out of 20. So the value that we see right over here, and hopefully you can see that it's in a bit grayed out, is basically 1.889%. So call it 1.9%. So you've got a 1.9% chance that you're going to get 20 out of 20. If I now change this to 19, there is an 8.3% chance that you're going to get 19 out of 20. And then we do this again for 18 points. And there is a 17.3% chance that you will get 18 out of 20. So 17.3 plus, what did we do here? 8.3 plus 1.9, add those three things together, and that should come out to be about 27.5. If we want to look at what is the probability that you're going to get a B on this exam, so again, the high value that we're looking at here is going to be 17. The low value, this is the first value we want to cut off. We want 16 in here. So the first integer after 16 is 15. So that goes in here. And this is telling us that there is a 44% chance that you get a B. If we want to do that down here, again, 17 out of 20. So there's the 22.8, let's say. What's the probability that you get 16 out of 20? So that's 21.3. So 21.3 plus 22.8, that should give you about the 44 that we have up here. For the probability that you get a C, we can come up here. Again, the highest value or integer points you can get is going to be 15. We want to cut off everything starting at 13. So in this case, there is a 23.1% chance that you get a C. And then for the last one, 13, all the way down to 0. So based on what we have here, this is saying that there is a 5.4% chance that you're going to get a bad grade on that 20-point quiz. If you wanted to, could you go in down here, look at 13, say, okay, there's my value, 12, add it, 11, all right, there we go, 10, add that, yep, all right, 9, yep, add that, 8, add that, 7, add that, 6, add that, 5, add that, 4, add that, 3, add that, 2, add that, 1, add that, 0, add that, add all those up. Could you do that? Absolutely. Does anyone here actually want to try to do that though? Because the value that we're looking at is literally right there. So looking at what we have, and I'll flip it back over so that you can see what I wrote down on my sheet of paper in a moment. Uh, we know that there's again, a 27.5% chance that you get an A, a 44% chance that you get a B, a 23.1% chance that you get a C, and a 5.4% chance you do really, really badly on the exam. Now, if we look at the, or sorry, on the quiz, if we now look at the exam, the high value we want to start with is 200. The low value, we want to look at 200, 199, 198, blah, 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 all the way down to 180. So the first integer we want to kick out is going to be 179. And this is telling us, based on the data, so again, based on the probability, 0.882% chance that you get any one of these points, the probability that you get a score that's in the A range is going to be 0.1%. Looking back, if we want to look at what is the probability you will have a B in here, the highest point total you can get is 179. The lowest points that still get you a B is going to be 160. So the first number we want to kick out is going to be 159. So this is telling you that you have a 79.7% chance that you get a B. Go back, we look at what are the chances that you get a C. So that's going to be 159. The lowest number of points you can get while still maintaining a C is going to be 140. So there we go with that. There's a 20% chance that you're going to get a C. So 20, let's call it 20.2% chance that you're going to get a C. And then this last one, the highest points we can have in here is 139. The lowest value here is going to be 0. And you can see that there is a 1.2905 e to the negative 0.5. Does anybody know or remember scientific notation? If you want to give a thumbs up, that's completely fine. If you don't remember it, don't worry about it. I will be boring you to death with it. So 1.22 e negative 0.5. So I'm going to flip this back real quick. All right. So this is what was written. Let me make sure that you can all see that. What was written in there. What this is telling us is we have 0.1234,122. This is the probability that you're going to fail the exam. Is there a chance? Yes. Is there a good chance? Right? So you have to move it 5 times. So 1, 2, 3, 4, 5 times. But because you're moving it backwards into decimal territory, that's why we have the negative here. If we put this into percentages, this would be 0.0012%. So based on the assumption that you get, say, 82% on your exam, or you've been 82% on quizzes, homeworks, and all that sort of stuff, there is a 0.0012% chance that you're going to get a really bad grade. So that is extremely small. So for purposes of looking at this, we can think of that as basically being roughly no chance at all that you're going to fail or get a really bad grade. And that was already a lot, huh? So, based on the calculations that we just did here, you can see all these different percentages here. And now, question that I can ask all of you, and this is, again, type of a question that you should expect to get on the exams, or the two exams in the final. It's a question about how do you interpret this data here and how do you feel about this data here? So, for example, looking at what we have here on the quiz, according to this, there's a 27.5% chance that you get an A. Whereas with the exam, there's a 0.1% chance that you get an A. Here, there's a 44% chance that you're going to get a B. Over here, there's a 79.7% chance that you're going to get a B. 23.1% chance that you get a C versus a 20.2% chance that you get a C on the exam. 5.4% chance that you do really badly on the quiz, and essentially no chance at all that you're going to do really badly on the exam. So based on those values, thing that I have to ask all of you, what would you rather be doing? Would you rather be like, say, take the quiz where you have 28% chance, so roughly 1 in 3 chance that you can get an A, but there's a chance that you can do really, really badly on it versus, say, an exam where based upon how well you do on, again, based on what I said you do on these exams, there's a very small chance that you're going to get an A, but there's virtually no chance that you're going to get a bad grade. Between those two, which one would you rather be dealing with? The one where you have a chance at a really good high, but you also have a reasonable chance of having a really bad low, versus one where you can't be that high, but you can't go that low either. So what do you think? And I am looking for responses from all of you. If you want to type something in the chat, you can do that. If you want to unmute yourself, you can do that. And because this is opinion, I will say as long as your opinion is based on what we were talking about, I couldn't care less what it is. Okay. So hopefully everyone just saw what Audrey put in. If you need to have A's, definitely. What about for the students that don't necessarily need to have an A, they just need to say pass the class?
I
What
feel
do you all think?
we all
Go for it.
strive to get A's, but people who take multiple other classes, obviously the exam would be a nicer cushion for a grade.
All right. So potentially nicer thing for your grade. And again, when it comes to uh like the risk that's associated here, if you had two choices, hey, you can get an A or you can fail. versus I can guarantee a B or a C. You ain't getting an A, but you ain't gonna fail. Which one would you rather have? And that is the correct answer is up to you. Uh, one of the weird things that happens when we try to make decisions, one of the weird things that happens when we start looking at these risks and all that, I can tell you the risks, but it's on you to make the decision. And as long as you used good methods to make that decision, it's a good decision. What happens does not matter. What matters is you did the best you could. So we're going to have a lot of other things that pop up like this. Um, Part of what's going on here is we're asking, or data that we're looking at, quiz versus an exam. And you can see that there is a tremendous difference when you take that value of n and you raise it up. Uh, let's say we're talking about the class in particular. If you are an 82% student on the homework, the exams and everything else, and based on your last math class, what are the chances that you're going to fail the class if you're 82%? And if we were to do this all over again with the full 1,000 points that all of you have the opportunity to get, what you're going to find is that at, like, say, 82%, you're basically getting a B. There's going to be a small chance you can get a C, but basically you're guaranteed to get a B. No chance of an A, no chance of basically getting a bad grade or failing. And with the data that we have here, as well as say with the data that all of you were looking at for your whatever classes you're interested in, the number of, I told you that the number of students that you're looking at has to be 100 or more. That's because of the confidence interval that we place around all of those different professors. The more students the professor is taught, the narrower the range of that confidence interval is going to be. So we get a much better idea about what their true passing rate will end up being. And then uh, with that first homework, when you're looking at everything and you see one professor passes, say 80% of their students, one professor passes, say 45% of their students, uh, which professor would you rather have? Most of us would, if you're looking for a passing grade, you'd want to go for the professor that's going to pass 80% of the students. But like what Audrey was saying, for her program, she basically needs an A, which is totally understandable. And with that A, uh, what if the harder professor, uh, it's say they pass 40% of their students, but 30% of their students get an A. Whereas with the other professor, where you have 80% of the students passing, let's say only 15% of their students get an A. So now who would you rather have? If all you need to do is pass, you definitely want to take it with the professor that passes 80%. But if you need an A, you'd probably want to take it with the other professor and then work your butt off in that class. So uh, that's getting into decision analysis, that's getting into risk analysis. Uh, what do you want to do based on your circumstances? Again, as long as you make an informed decision based upon the information that you have, that's essentially where all of this is going. Okay. So there's, uh, like I said, with the class itself, you can manipulate that. You can come up with different things. really quickly before we say go to break. I'm gonna flip this back over to my screen. So let's say, and this is a problem that came up. Let's say you're looking at, or you're working in a hospital, and you know that, say, the hospital infection rate for a certain type of surgery is, let's say it's 2%. Let's say you go back and you look at, uh, let's say 300 patients that had a particular procedure. Okay. And we want to figure out what is the probability that when you're looking at all of these, you might find that there is, say, five, or you look at 300 random patients that got the surgery. What is the probability that you're going to find that the number of infections you found out of 300 is five or less? And looking at the value that we have right there, is 44%. So if we make this a little bit uh, more direct and to the point, so for talk, this gets into something called quality control and quality control sampling. It's something that generally is not done at a hospital, but could be of a benefit. So again, let's say we're looking at hospital infection rate is 1% because I just changed it. Let's say we're looking at the probability that you, out of 300 people that have a common surgery, uh, there are 6 people or less that have um, infection. So we can see right here, approximately 92% of the time when you look at all of these surgeries, or out of 300 surgeries, you would expect to see 6 or less in infections, okay? Now let's say we're talking about one doctor in particular who again has done a lot of these. And let's say that you look at his or her infection, post-op infection rate, and they've performed on 300 people or more than 300 people, but you're just randomly grabbing 300 people and you found that they had 9 infections. Does that seem like maybe that doctor has a higher infection rate than, say, the average? So if we look at this and we change it uh, to say 8 or less, that's 94.7% of the time, so roughly 95% of the time, we would expect to see 8 infections out of 300 or less. So if you now see 9, that's telling you that you're in, like, say, the 5% territory. We can come back down here, put in the 1%. We're looking at 300 in patients, and we want to look at 9 people that were infected exactly. And that is the probability that you'll find 9 people exactly that were infected. If we want to look at 9 or more people, we have to do 1 minus this value. So basically it'd be, say, 5% of all the doctors that do this particular surgery, or say 5% of the doctors that do surgery, you'd find 9 or more patients that had an infection. Does that seem like it's an elevated value for any of you? So just looking at some of the stuff that you put up here real quick. So Audrey was just asking, will we be given the p-value? You will be given a way to calculate it, okay? Um, and quite literally on the first exam as well as the final exam, there's a question based on basically what we just did with the exam. And we're going to pretend that on one of them, it's going to be a 200-point exam, our final exam. On the other one, it's going to be a 300-point exam. And then you are going to be given the chance or the enough information to figure out what is the probability that you're going to get any given point on the exam. And then you basically go through and do the calculations that I just did here. So there's a lot of stuff that we can do with this binomial distribution sheet that we've got here. I will send you a link to another set of videos that I did. Unfortunately, don't think any of the material we covered today sounds all that good. And I've had complaints that some of it, you can't even tell what I was saying some of the time. So I do have to remake those. But again, coming to it from the point of view of risk, if you knew that you were about to have a surgery with this person who, out of 300 surgeries, had 9 infections or maybe even 12 infections or something like that, would you maybe second guess what they were doing or second guessing them in their ability to say clean their hands, use sterile equipment, and that sort of stuff? So, and again, that's something that you would need to take into consideration in whatever answer you come up with, assuming you made use the information that was available. You just have to go and do it. Okay. So let's give it about 10 minutes or 10-minute break. I'll start up again at say 7:05. We'll do a little bit with the with the Poisson distribution. And then I'll show you a little bit on how to use the multiple file. And if I think I might have to upload it. So that'll give you all a chance to get the multiple file and work through a couple problems with me. And then after that, we'll call it quits for the day. All right. Let's see. I think I uploaded it, but not. Clearly it didn't. All right. So clearly I need to get off my butt and actually do that. So module. Ooh, week 3 homework. Yay. And drop that in there. And then of course, have to publish it. So now all of you can actually get to it. And I'm just gonna sit here because I think if I want to go and to try and grab something out of one of the vending machines, I'm probably not gonna be able to do it and be back in time anyway.
I have a quick question while you have your Canva open. So for next week's assignment, it says, let me look at it so I can give you the right one I see. There's module 2 that has an assignment, and then there's a lab 2, and then I don't see anything underneath lab 2 like for us to do. Like it just says submit. Is it the same as
Yeah, I'm trying to redo uh like all these classes. So essentially the first part of the class, we're gonna have these computer labs from time to time. And for week 2, That's use the, or this is the homework that I want you to work on. You use the exam one calculator. When you open up exam one calculator, you end up using the conditional probability stuff that is here to do that. And I still haven't come up with an alternative homework for this yet. So because I'm apparently lazy like that, probably just end up giving everyone 15 points for the what is it called on here? For the lab too, since I didn't put anything in there yet. So yeah, sometimes I get a little bit overambitious with these things. But what I'm trying to do, what I want to do eventually is have like homework that you can do that's going to be similar to, say, something you're going to have on the exam or something that you might be interested in or have a personal interest in at some point. And then uh, the lab will be using SPSS or Excel to answer questions. And unfortunately, I haven't gotten to the point where I've broken apart the lab assignment from the homework. So, oh well, just means you'll get 15 points for free. Anyone gonna complain?
Thank you.
Yeah. Yeah, future classes, there will be something else. What exactly is that gonna be at that point? Um, I don't know because I haven't thought of it yet. Because I haven't had time to think. So. I'm gonna stop sharing my screen for a moment so that I can actually look at my email and you don't get to see what I'm doing. Alright. And it looks like a lot of your classmates are having some issues or still having some issues with the video accessing the videos. So I'll have to put something about that in an announcement. And hey, since I got time right now, might as well do it.
Will we have a WebEx video like you did for the last one? Is that what you were just saying for like how to do the next homework, next week's homework?
So I will exit out of here. So share my screen again. So if you go to the cloud recordings, you can see the web extra that was done yesterday. I just published it at the beginning of this class. So if any of you here are still in Canvas, you should be able to go to uh, Zoom 1.3, open this up, go to the cloud recordings, and you should be able to watch this. And again, should. I know there are some of you that had some issues with that. I ended up sending links to everyone. Or everyone that asked. Hopefully that they were actually able to get it. But I'm about to make an announcement about that. So Be nice if I could actually spell. That'd be weird. All right, so talk a little bit about the Poisson distribution. When it comes to the Poisson distribution, there is some weird stuff that can happen. Let me stop the share real quick, flip the camera over so that we can see this a little bit better. So I said basically that the Poisson distribution can have any value from, say, 0 to positive infinity. It's going to have a mean that is lambda. So this is the mean. Square root of lambda is the standard deviation for this. And we can only deal with, say, integers. Now, if you think about certain situations like I was talking about earlier, let's just keep it general, talking about, say, sports. Or in a moment, we're going to be talking about rates or rates. It's like the number of people that walk into a grocery store, the number of people that walk into your ER, so on and so forth. They can only enter as integers, meaning you can only have, or if someone enters the ER that you're at, someone that enters the grocery store you're at, they're counted as a whole person. But because we're dealing with averages over time, the mean can actually have some sort of a decimal. So for example, if we look at, say, the Detroit Tigers and how many points do they score per game on average this year, You can look that up. I honestly don't know what that's going to be. But let's say the average that the Detroit Tiger number of runs the Tigers scored in a game so far this year is say 5.4. Can you score 0.4 of a run in a baseball game? Absolutely not. But because we're dealing with the average, we can and will sometimes have a decimal value. Trying to make sure that all of you can see this too. Once we know something like that, we can ask a question like if you watched the Tigers game last night, the Tigers scored 9 runs. And we can ask a question like, how rare is it for a team that scores 5.4 runs per game on average to score, say, 9 runs exactly, or we could say 9 or more runs, okay? If we're looking at 9 runs exactly, we would use the Poisson PDF, plug in the values that we have, and we'd be good. If we're looking for a range of values here, this is where we'd use the Poisson CDF to do this one. Unfortunately, because of the way these types of things, or the way that the calculator is set up, we would have to do, so this is either with your graphing calculator or with the Excel spreadsheet that I gave you, we would need to know, because we want to look at 9 points or more, we have to get rid of 8 points or less. So this is getting back to the formula that I wrote out earlier last week. Probability that an event occurs plus the probability an event does not occur. So I'll just say happens over here and does not happen over here has to equal 1. Because I'm looking at 9 points or more, I have to get rid of the probability that they score 8 points or less. So we can think of this as probability 9 points or more plus the probability of say 8 points or less is going to be equal to 1. Because of the way all the calculators work, we have no ability to actually calculate what this is going to be. All of the calculators are actually going to just calculate this. So how do we get this when we've got this entire equation written out here? Well, we want this, we can calculate this, we already know what this is. So once we get this done, probability that Tigers scored 9 points or more is going to be equal to 1 minus the probability they score 8 points or less in a particular game. The same thing applies if, say, I want to look at, so going back to, say, exam grades. If I want to know what is the probability that you get, say, 170 points or more on the final exam, I have to subtract off, I actually have to do this as 1 minus the probability that you get 169 points or less. So it's the same idea. We have the same issues. So we can come in and look at this. If I'm using the exam 1 or the exam 1 calculator, I have to go to the Poisson distribution lambda, so that's going to be my average. I said the average was 5.4. The high value that I'm looking at is going to be 8 points. And unfortunately, the way that this thing is set up, even if I get rid of this low value here, that's not going to affect anything here. But what I need to do in this particular case, and the same thing is essentially going to happen if we're trying to do the same thing with the binomial distribution, except that we don't have to worry about the probability of getting 0 points for that, which I know is weird and it is a bit confusing. But in this case, we would say the probability that you get 8 points or less, or sorry, that the Tigers get 8 points or less in a game is going to be 90.2%. If we want to know what is the probability they get 9 points or more, it's going to be 1 minus 90.3%. So let's call it 9.7% or something like that. Okay. So I'm going to come out here and say about 9.7% for that. If you are into sports gambling or anything like that, being able to do these calculations can potentially help you decide whether or not something you're trying to bet on is actually worthwhile or not. If I want to know what is the probability of the Tigers getting exactly 9 points, I can come down here, say they get, and I said they get an average of 5.4 points, and I'm looking at 9 points exactly. And I can see that there is a 4.85, so call it like a, or 4.8595, 4.86, 4.9% chance that the Tigers will score exactly 9 points based on the team's average of 5.4 runs per game. So for those of you that are into sports betting, something like this can help you make better decisions. And something we'll actually look at a little bit later is basically most of the time if we're talking about gambling of any kind, the correct answer is no, it's not a good decision. But we will actually see in a couple of weeks that sometimes, yeah, it actually is. Yep, and statistics will tell you that. But we will get to that stuff when we get to it. For now, what I want to do is hopefully all of you were able to download the multiple file. This is basically what it looks like. I wish there was a way that I could make it so that I can zoom in on everything and we can see everything that's going on. Unfortunately, if I zoom in too much on one spot, we miss out on another. But I will try to make this as big as possible for most of what we want to do. So what we're looking at here, and if you watch the new video that I posted, you have, or you'll see that I'm doing these same types of calculations. Again, because what we're studying here does actually work. I'm going to flip this over real quick. It does actually work if we want to talk about, say, the ER at a hospital that you might work at, or say the doctor's office at the or the for scheduling patients at the doctor's office that you might end up working at, or say if Audrey gets her, or when Audrey gets her doctor's and physical therapy, uh, this could help her try to schedule patients for her facility, if say she's going at it alone, or if she's gonna be working in like a physical therapy clinic with other doctors, this sort of thing will help out with that sort of thing as well. So uh just to keep up with say what Audrey might be or will be doing eventually, let's say we know that in general, a physical therapy session takes, say, 30 minutes. How long does one actually take? Honestly, I don't know. And honestly, I probably should be going for physical therapy for a bunch of different things, but I haven't made it there yet. So I'm just gonna say, let's pretend that it takes 30 minutes. When we're looking at uh, the arrival rate here, and the service rate here, these are essentially say the number of customers that are coming into Audrey's clinic. And let's say how quick or how many patients each doctor at Audrey's clinic can actually see in a given hour. So both of these are in terms of per hour. And then up here, this would be, say, the number of doctors that happen to be at her particular clinic, okay? So I said it takes half an hour per patient. Is that realistic? Honestly, I have no idea. Um, but if we're working with patients 30 minutes at a time, that means I can handle, or each doctor there can handle 2 patients per hour. And let's say, for example, because word got out about Audrey and some of the other people that she's working with, they know that everyone there is really, really good. So let's say there is a call, or essentially there's going to be 10 people per hour that want to come in to this particular clinic. Okay. Now, if we're looking at the number of servers, so these are going to be the number of doctors that are working at this physical therapy facility. Uh, if I type in 5 here, you can see everything that's in this grayed out area here, just it's given to be all sorts of error messages and error messages that are specific to Excel. And basically what's happening here is there are 10 people that want to come to her clinic per hour, and the 5 doctors can handle 2 patients per hour. 5 times 2 is 10. So what's happening is they've only scheduled the minimal number of doctors required to handle the patient load. And things are going really bad here. Part of the reason for that is we are assuming that the doctor can see an average of 2 patients per hour. And if you've ever been to a doctor's office, the doctors might say schedule you or have say appointments 9 o'clock, 9:15, 9:30, 9:45, 10, and so on, under the assumption that the doctor's only going to spend, say, 15 minutes dealing with you. Last time I was in the doctor's office, I actually pulled a bicep, tore the tendon for one of my biceps completely off. So when I got in to go see the doctor at my where my general practice physician is at, uh, she walked in, went, "Yeah, you need surgery on that. I'll sign off on that," and basically walked right out. So my visit was literally 1 minute. That's not going to happen for everyone else. Some are going to take 15, some might take 20, some might take 25, some might take 45. So for that reason, based on what we've done here, Excel is going completely nuts and it's trying to tell you this doesn't work, this is not good. So what we need to do is to come up here and actually have, say, 6 doctors. So now these 6 doctors can handle 6 times 2 on average, so 12 patients per hour. But the demand for the clinic is only going to be, say, 10 patients per hour. So what does that actually do? When we look at some of the things down here, some of these are fairly easy to contemplate, fairly easy to deal with. So probability, there are no customers in the system. So this is the probability based upon what we have here that a patient walks in and there's no other patients in the building, okay? So you can see that that's actually going to be fairly low. This is also assuming that they're not, say, the first patient of the day. This will be, say, 2 hours after the clinic opened, 3 hours after the clinic opened, something like that. What's the probability of someone coming in during late morning, early afternoon, evening hours or whatever, and there's no one there based on what we have? The probability that they're going to be the only one in there is low. Down here, this is going to be the number of patients that are essentially sitting in Audrey's waiting room, waiting to see her and some of the other physical therapists at her facility. This is going to be the number of patients that are, say, in the building. So 2.93 on average are going to be in the waiting room. All the rest of these are essentially going to be busy working with one of the physical therapists at any given time. The 2 numbers that I have here are how long the patient is going to wait out in the waiting room, and then the average amount of time that the patient is going to stay, say, in the facility. If we're thinking about this, say, in terms of an ER, this is going to be the number of patients that are in the waiting room, or how long a patient waits in the waiting room before being admitted. This is going to be the amount of time a patient spends either in the waiting room or, say, in an ER bed in back. Because of how these things are calculated up here, these are in a per hour value. So I can look at this and say 60 times, so equal to 60, then asterisk this. So this is telling me that the average patient is going to sit in the waiting room for 17.6 minutes. And the average patient is going to be either waiting to see Audrey and her colleagues or working with one of them, okay? And then down here, this is the probability that a patient coming in is going to have to sit there and actually wait for someone to arrive or to get called back to go through a physical therapy session. If I come up here and I change the number of servers from, say, 6 to 7, so now we're saying there are 7 doctors in Audrey's clinic that she's at. Look at what just happened. By hiring that one extra doctor, the amount of time that a patient's going to wait in the waiting room went from 17 minutes on average down to under 5. And the amount of time that a patient's going to spend either, again, with a physical therapist or waiting for the physical therapist goes from, what was it, like 45 minutes to 35 minutes. So if you are concerned about, say, customer care, if you're concerned about, say, the rating you're going to get on like Google Maps or whatever for your facility, perhaps having an extra couple people in there would actually be beneficial. Looking down here, there is this area called economic analysis. And this area down here would be used to say justify to higher ups at say an ER or say to the business manager at Audrey's clinic why we need to have say 7 doctors on staff or 8 doctors on staff or whatever it happens to be. Okay. Uh, this down here where it says the service cost per server, that is essentially the hourly wage of the person, or say of the doctor, or if you watch the video that I made of say the nurse practitioner, the physician's assistants, or whoever you might have in your clinic, you might have in your ER, or whatever it happens to be. So it's hourly wage plus average hourly benefits plus all that other stuff. So even though I've got it here as say $50, in general, this might actually mean that say one of the physical or whoever it is being paid say $35 an hour, but they're getting say 10 hour or $10 per hour in say benefits. $5 an hour is also spent on other types of insurance, like unemployment insurance, that sort of thing. The value up here for it says the cost or the waiting cost per unit. Can actually be fairly difficult to calculate if we want to do it correctly. Um, if so, if we're not talking about Audrey's clinic anymore, let's say we're talking about the Starbucks by my house or something like that. Okay. Uh, how much is or what is the waiting cost per unit, say at a Starbucks? Let's say, for example, you're driving around and you're thinking, hey, I want to grab a coffee. There's the Starbucks that's right there. It's right before you get on the expressway, so it's very, very convenient to do it. And I will say the people that work there and have worked there in the past are actually really great people. Management and all that sort of stuff is great. Um, but you look and you see that there are 15 cars in line already. Are you going to say, hey, there are 15 cars in line over there, but I want to grab a coffee. I'm going to grab one from there and I'm just going to wait in that line, be number 16 in line? Or are you going to look at that and see there are too many, or think to yourself, there are too many people in line. I'm going to drive off. That's where this waiting cost per unit comes in. So, yeah, go ahead.
I was also wondering, just based on that example, it is a good point that we don't know how many people, we know we could see how many people left,
Yeah,
but we can't see how many people didn't even come in. But also we
right.
don't know what they were going to get. So for example, maybe someone was going to get a venti black coffee and leave, but somebody else was going to get an order for the entire office.
Right.
So is there
So,
even to guess to have some sort of validity in trying to assess that?
um, sometimes you have to make some guesses. Sometimes you have to change the value in here a couple of times. And gonna be honest, with homework 3, that's one of the things that you're actually gonna be doing here. Uh, but let's say at this particular Starbucks, we know that the average order is, let's say, $10, okay? And instead of 15 people in line, let's say there are actually 10 vehicles in line, and you drive by and you notice that there are 10 people in line already, even though they do the best job they can to get their orders out as quickly as possible. You know that with 10 people in line, it's probably going to be, say, a half-hour wait for you being in the end of the line. So you decide you're going to move on and you're not going to get that coffee. So in that case, we would say that the Starbucks just lost $10 in sales. And again, why is it $10 in sales? Because that's the average order or value of an order at this place. And again, I'm making these numbers up, but just so we have an idea of where this comes from. And there are 10 people in line. So that $10 lost divided by 10 people in line. So in that particular case, the waiting cost per person is going to be $1. Now, so if we're talking about an ER, uh, when I tore the tendon right off the bone in my arm, did I need to go see a doctor? Yes. Um, did I have to go to the ER that I went to? Absolutely not. This was a non-emergency visit. So I had my choice of going to anywhere I needed. And in all honesty, when I was driving to the ER that I went to, I actually drove past a one of those critical care facilities. I figured since I knew that I tore something in here, they might want to take, say, an MRI or something like that. Critical care is not going to have the MRI. So I drove all the way to the ER and then waited literally 8.5 hours from the time I walked in until the time I was done. Okay. And in that whole time, all they did was take an x-ray. I'm not sure how far any of you have gotten into your medical careers and medical understanding, but in general, if you've ever had an x-ray, x-rays are really good for bone. You can see bones. Last night I was talking with a friend of mine. She had an x-ray done. They found a spot on her lungs. She is a smoker and a heavy smoker. So that could be like a cancerous tumor or something like that. X-rays are really good for that. What are x-rays totally useless at? Soft tissue. So I had a soft tissue injury and they're giving me an x-ray. Had I known that was going to happen, I would have rather gone to the critical care place and gotten the same service and been in and out in 30 minutes and had a potential reference for an orthopedic surgeon after that. So had I known what was going to happen, uh, literally the amount of money that insurance paid for surgery, the amount of money I paid for surgery, the amount of money insurance paid for the ER visit, the amount of money I paid for the ER visit would have been, say, $30,000 to $40,000. So let's say it was $40,000, okay? Now, if there were 8 people in the room ahead of me, or in the waiting room ahead of me, and I saw that and I decided to leave, that means that the hospital is now out $40,000 in revenue. So the waiting cost per unit here would be $40,000 divided by 8 people. How much does that come out to be? And I see there's a question here in the chat. Well, I'll have to check that out, Audrey. Um, so when it comes to the waiting cost per unit, had I gone somewhere else, the hospital would be out $40,000. Um, actually,
Would it
I'll
be
show you how to.
500?
I'm sorry.
Would it be, oh, sorry, if it was $40,000 divided by 8 people, would it be 5,000?
Yep. So in this case, had I known what was going to happen, and I will just say the next time I have a non-life-threatening injury like I did, Am I going to drive to this particular ER? Hell no. So we can now think of this as that whole hospital system has now just lost, say, another $20,000, another $30,000, another $40,000, however much it would have been, because I had to wait so long and had such a bad experience that time. So this average cost per waiting unit, uh, is there a way to tell exactly what the value is? Absolutely not. But if we can reason it out the way that I just did, where I said, I will never go back there because I had to wait so long and there were 8 people in the waiting room ahead of me, that makes the waiting cost per unit $5,000. Okay. So, uh, I actually applied for a job at DMC down in Detroit. And if you watch the video, I talked about this as well. But just to make it really quick, I talked with them and I actually talked with them about the material that's in, or on this Excel spreadsheet. They don't believe there's a waiting cost per unit because they believe no matter what, they're going to get the same number of patients. And I looked at them and well, and I'm looking at like executive vice presidents and all that, and I'm applying and interviewing for a job. And I looked at them and I said, what's the next biggest hospital near here? Oh, it's the main campus of Henry Ford. How many people are sitting right now in the waiting room of the ER at Henry Ford Hospital? If you are so good, why are they over there? Why aren't they in yours? Every single person that's in that other hospital over there is part of the waiting cost you are incurring because you have such long waits. And they didn't want to admit uh, that people wouldn't go to them and went to Henry Ford instead. If it's an emergency, uh, you're going wherever you're going. You're having a heart attack, they're not going to try to say you're in Flint, or let's say I have a heart attack and I'm here in Flint. They're not going to be driving me to say the Beaumont Hospital or whatever it is that I could have gone to in Troy, because I'll probably be dead by then. I'm going to whatever the nearest hospital is, and I get that. But because if I have the non-life threatening injury, I have a choice of where I'm going to go to. And should something happen to me, say here, stumble and say twist my ankle or something like that, what facility am I going to go to? I'm going to go to the Beaumont Hospital in Troy because that's the closest one to here. Is it a bit of a drive to get there? Yeah, but I've always had really good service there. So again, when it comes to this waiting cost per unit, is there any way to accurately calculate it? The answer is absolutely not. If you want to look at it from an economics perspective, the waiting cost per unit, you calculate that by looking at how many people are going to your nearest or to say, the closest similar facility. So like for Audrey, if she's in her clinic and they have, say, 10 people that want to come in per hour to her clinic because they know how good she is, the waiting cost here, you could calculate that as, say, how many people are going to say, the substandard clinic that's, say, 2 miles away or something like that, just as an example. So since there is no firm number here, we do have to look at different values. And just so we can do this, and I'm going to do this a bit quickly, just so we can see the kind of things that are going on. But again, let's say we're talking about Starbucks. We know at Starbucks, and this is something, if you go to a Starbucks where they have a drive-through, all of this information is actually available on a screen at that Starbucks, they have essentially, or they want to make sure that this value here is actually under 5 minutes. So from the time you get in line until the time you get your coffee and you drive away, they want to make sure that is under 5 minutes. So we can look at this sort of stuff really quickly. And if you watch the video, and I will have to upload all this stuff later to that YouTube channel if you can't get it, I go over this a whole lot slower. But let's say at the Starbucks by my house, they have 60 people per hour that want to get there. So that's one person per minute. Let's say that on average, it takes an average server or an average Starbucks employee, say 5 minutes to make a drink. Is that a bit long? In all honesty, yes, it is. 5 minutes per drink, but we have to look at this as how many drinks will that be per hour? At 5 minutes per drink on average, that's 12 drinks per hour. And how many people are going to be in there making these drinks and all of that? Let's say the one by my house when they're really busy. Let's say they have 6 baristas doing that, okay? Now, let's say when the lines get too long, you do have the people that are coming out. So let's say the average waiting cost here is $2 per person that's waiting. And if we're talking about the average barista, let's say they cost the company, say $24 per hour, okay? Based on everything that I have here, uh, from the amount of money the Starbucks pays their employees, plus the amount of money they lose because of having too many people in line, the total cost here is, say, $160, okay? Let's say they hire one extra, oh, and we can see here that the average wait time for a for a customer is going to be 7.94 minutes, call it 8 minutes. I said we want to get that as close to 5 as possible. So we may have to add an extra barista here. So let's say what happens when you've got 7 people making the coffee drinks and all that. And again, the average barista can make 12 drinks per hour. We're still not hitting our 5-minute thing down here. And honestly, the way that this is set up, we're never going to hit 5 minutes, but we can get really close to it. By adding that extra barista, it now costs the company $180 per hour. Again, based on everything we have here. We can add, say, another barista on here. So let's say there's now 8 people. And I'm pretending like they don't bump into each other and everyone has their own workstation so they can make everything. Again, we're not hitting our metric here. And we've now raised the cost per hour for the Starbucks to $202.50. Okay. Now, let's say you've got a barista who's been working there for quite a while. So instead of 5 minutes per drink, it only takes them 4 minutes per drink. That means they can make a drink in 15 minutes. And here I am assuming that everyone on this particular shift is going to be an experienced barista. Because of that, they're going to make a little bit more money. So let's say they now make $28 in compensation instead of 24. And you can see here, because of that, they're now well below their 5-minute limit per customer. So 232. And I'm gonna make this a little bit smaller, and I apologize for this. Actually, I'm gonna do something here So I can actually see what's going on and we can still stay zoomed in. So this is going to be equal to whatever this thing is. So now I can zoom back in and we can see pretty much everything that's going on, hopefully anyway. So if I have, say, 7 baristas, we are still hitting our under 5-minute thing. We just had the cost go down. If I have 6 baristas based on everything, we are still under our cost here, or under our time here. If I drop this down to say 5 baristas, so now we're at $152, but we just went over the time limit, so we might need, again, so we might need 6 of them. So if we have 6 experienced baristas, this is going to come out to be $177.14. Going to change this back to 12, and then I'm going to change this back to $24 per hour. And now, if we want to get as close to 5-minute wait that we have here, again, I put in the 8 baristas. Are we hitting our under 5-minute mark? Absolutely not. But look at the total cost here. So from a business point of view, what we're looking at here, and for those of you that may be working or may have been working in a place like, say, Starbucks, or someone that might be working at a place like, say, Kroger or whatever, and you've been working there for a while, there might be some of the managers that are trying to, like, say, push you out because you make so much more money than a brand new cashier or brand new barista would. But look at what happens. If I have 8 average baristas, it's costing me $202.56 per hour, and I am close to meeting my goal of having everything done in under 5 minutes. But if I hire 6 experienced baristas who make more money, I'm actually saving what, about $25 an hour by having 6 good employees that are paid more, as opposed to 8 average employees uh, that are paid less on average anyway. So what do you think about that? And I will say for those of us that may have a little bit more experience in doing certain things, uh, and I at the Starbucks that I'm talking about with former managers, they actually would try to push out the experienced people so that they could get more cheaper labor in there so they could drive down the cost. But those managers were only looking at how much the employees are being made and not looking at how much money they're losing, because the freaking line at this Starbucks would get to be like around the corner. And if going to be talking about, uh, say, a couple of the women that I knew who worked there. So Danny and Jessica, they were really good. They could actually get those drinks out in 20 minutes, or out in 3 minutes. So that means 20 drinks per hour. But because they were there and they were also supervisors, let's say they cost the company $32 per hour. Are they worth it? So looking at what we have here, we are definitely well over or well below our waiting time. And if you've ever been to a Starbucks, are you going to complain about how I was in and out quicker than I thought I was? 1 star. No, it's going to be I was in and out quicker than I thought I would. 5 stars, right? So now let's see what happens if we have 3 of these employees. So 3 times 20 is 60. So we're getting into that issue where we're going to have the infinite backup and blah, blah, blah. Bad things are going to happen. So oops, got to make that 60 again. Going to make this 4. So look at that. We are still under our 5-minute wait time by having 4 really good supervisors. So people that are a lot higher paid than a brand new employee, but really talented, really good at what they're doing. What is the total cost there? $137. So when we're looking at this, if I was the manager of that Starbucks and you told me I could have 4 highly paid, well-trained, say supervisors on a shift, or 8 average people on a shift, give me the 4 highly trained ones. No doubt about it. So, and one of the things you can do with this as well is if you think that you're, say, underpaid for whatever it is you do, you can actually go back and do this type of economic analysis and say, well, if my total compensate or if my hourly wage was, say, $18 an hour instead of $14 an hour, because I am so good, here's what the total cost is going to be. You go hire someone who's new who isn't as good as me and say doesn't care as much, blah blah blah. You pay him 12 an hour or whatever the rate is. Here's what it's going to cost. Why is it going to cost that? Because your lines are going to get backed up. Your lines are going to get backed up. Your store is going to have negative reviews. People won't come in as much as they used to because they know that they're going to wait. That costs you money. All that money, where does it go? Goes to the grocery store across the street or the one that's a mile away or whatever it happens to be. So I know that was a lot of stuff. I know that was pretty fast. I also know that that was so yeah. And so I know that uh, that was a quick and ranty and all that too. But this everything that's on here is something that um literally places like Kmart, Meijer, and Walmart have actually figured out. Part of the reason why, if you go to any of those grocery stores now versus say 3 years ago, there are all those self-checkout lanes. It's because of the cost savings that's here. Uh, so in 3 minutes, I'll try to do this. Uh, and this is actually similar to the homework that you're going to have. Let's say it's a busy Saturday or Sunday. So there are 120 people that are going to be coming into whatever grocery store it is per hour. Let's say the average cashier can handle, well, let's say it takes 5 minutes for a cashier to check out the average person. 5 minutes per customer. Again, that means that they can handle uh, 12 customers per hour. 12 times 5 is 60. Based on that, the minimum number of cashiers you would have to have would be 13. So again, this is the minimum. Let's say the average cashier makes $22 an hour at wherever you're at. And the waiting cost here, so again, how can we calculate this? Look at the number of people that are in line on average. Look at the value of everything that's in the abandoned carts. Look at all the people that are, say, going to the other grocery store that's over wherever. So let's say, uh, like last time I bought groceries, for the week, it was about 250 bucks. So let's say it's $25 per person that's waiting in line. So based on all of that, you've now got the total cost is now say $560 per hour to barely or to get every one in here processed and all that sort of stuff. Now let's
I
say,
have a, I have
you've
a quick
got,
question.
sure,
So the $560, that's what the stores are losing because they have so many people in line waiting and they
that's not necessarily losing, that's just what it costs. So the total cost there is how much are you paying those 13 cashiers plus how much money is basically not coming into your store per hour because of the wait time and all that.
okay.
So some of this stuff is really easy to calculate. 13 cashiers times however much they make per hour in salary and benefits and all that, and the insurance you have to pay. Easy enough for that. Again, how much does the company lose because people go somewhere else? I don't know. I'm just putting in numbers here to see what happens. Now, let's say that we're looking at some of these self-checkouts. Just as an example, the Kroger by my house has banks of 6 of these things. Okay. So if they open all 3 banks of them, there is going to be 18 different self-checkouts. But when we come down here and we look at the cost per server, we now have to say it's $22 divided by 6. Because this cashier now has to oversee 6 of these things. The hourly cost is divided by all 6 registers. And let's say to do this, you have to be a little bit better cashier than, say, brand new. So let's say they make $24 in compensation. So 24 divided by 6. It now costs $4 per self-service station. But let's say because it's the individual people that are doing this, instead of 5 minutes per customer, or say 12 customers per hour, we can only now serve 9 customers per hour. So $417 per hour based on what we're looking at. What was the cost before? So what was it? 12, and then what was it? 13 up here, or 11 or whatever it was, and then so you've gone from, in this case, $660 to 400 some odd dollars. So by having all those self-checkout things, is each individual person now slower? Yeah, but you have more people going through, number one. Two, because you've got one cashier looking at 6 registers instead of one cashier only dealing with one register, the company is now saving like the $200 and $250 or whatever it was per hour by having them in. Does that mean that everyone's going to be happy about it? So, okay, if I had it wrong, I apologize. So 560 versus 4, whatever it was. But anyway, for these companies, is it better for them to have all these self-checkout lanes? You betcha. Are they saving a lot of money with that? You betcha. All the stories that you hear about, or that I've heard about people that are, say, buying the uh, like 3 pounds of filet mignon, putting it on the scale, and then like saying it's banana. So instead of paying $100 for 3 pounds, they're paying 250 because it's rang up as 69 cents per pound or whatever it is. Are they losing money on that? Yeah. But is the money they're saving by having the self-checkouts more than compensating for that? Yeah. You want to stop customers from stealing like that, get get better cashiers out there. Maybe instead of having them overlook 6, have them overlook 4 registers at a time, something like that. But anyway, that's all that I have for this evening. Uh, like I said, I will make the video. Uh, sorry, I will make the video, all the videos. I will upload them to YouTube, and I'll be doing that probably during my office hour tomorrow. So if I can get everything uploaded as quickly as possible, everything should be visible for all of you by then on YouTube. Uh, and it will be for those of you that can get the videos on our Canvas site, you will have access to those even quicker. So if anyone has any questions, feel free to stay behind. If you are done for the night, I'll talk to you guys next week. All right? And if any of you do have any questions, feel free to unmute yourself and start asking.
I was just wondering, would it be more convenient for you if you could just make sure I'm on the right, if I did the homework correctly here or tomorrow? Because I could stay if you were available. It's up to you. I don't want to inconvenience.
Well, to do that, you'd have to kind of show me what you're doing. So you'd have to share your screen.
Okay.
And if you share your screen while everyone else is around, everyone else is going to be able to see what you did. So it does not matter to me. But if you're afraid that you might be doing something wrong and you might be embarrassed by it and you want to talk tomorrow, fine. If you're like, hey, I want to get this done as quickly as possible, I don't care what anyone else thinks about me,
Yeah,
and you
I'm
want to
kind of
share
in
it
that
with me,
boat and I'm not embarrassed. Like, I guess, like, if I'm doing something wrong, then it's a learning opportunity for everybody else, I
well,
guess.
yeah. Well,
Um,
there are some people that are would get embarrassed by that. Uh, just to be honest, there have been several occasions I've thought about instead of doing a final exam, have students do a final project and give a presentation. And a lot of the students really, really hated that because they were too afraid that when they came on or uh when they got up in front of everyone, they would make a mistake, they'd be embarrassed, and then everyone would be laughing at them. So they'd rather say take the exam by themselves in misery than embarrass themselves. So whatever you want to do, if you want to do it now, feel sorry, I've got to stop the share here. Go ahead and show me what you've got if you can.
oh, yes, I will. I'm just gonna, this is gonna be kind of crazy. How do I share my screen?
Okay. So fortunately, uh, so you can see down here, there's this
Oh,
green arrow that says share. So if I click on that, I've got the opportunity to share my entire screen, or I can share some individual thing. It looks like you're doing something. Okay.
I think I got it. Thank you. I was like, oh no. Okay.
Yeah. So again, when you're sharing your entire screen, um, I've shared my entire screen and you notice that all the things that are on there, there's nothing on there that's embarrassing. So there's nothing like naked pictures of whatever. It's
No,
just stuff.
50 tabs.
I
I'm a tab person, so
then I'm just gonna be honest. There was a student. They didn't realize that they had like or they knew that they had like the little file folder that just said like porn on it or something like that. And you could see some of the pictures coming up on the top. And then they shared their screen, and all I'm thinking is, dear God, I hope no one else notices. Dear God, I hope no one else notices.
yeah.
So anyway, okay, so looking at what you've got here, all of when it comes to the calculated values that you've got there, those should all be done by by Excel, and those should be the values that I was showing earlier. So, yeah. So like right there. So if you keep it just right there for a moment,
Mhm.
what you're showing me is that in Physics 104, whatever, I think that's the like introductory physics class. 47% of the students get an A. 90% of the students on average actually pass the class. But what I'm looking at right here is I see that 119. So it looks like there's only one professor that teaches that class.
Yeah,
Since you
and that's
don't have a variety, that probably wouldn't be a good one to look at.
so I noticed that for when I got to the second question, and then I used these this class in this class, which now I know are the same thing, but
Yeah. So again, looking at Physics 106, um, that might actually be the astronomy class. So again, because you've only got the two professors in there, those physics classes wouldn't be that good because you don't have much of a contrast there. If you've got the right idea and you're calculating everything the way I expect you to, it's just the two classes that you chose there, probably not good ones for doing this assignment with.
oh,
So I don't, uh, what, I might have already asked you, but what degree program are you in?
administrative health.
Okay. Uh, so there probably aren't any classes that are on there that would be part of the curriculum that you're doing. But if you go back, you want to stop sharing the screen for a moment?
Yes.
All right. So I will share my screen. I'm going to get rid of this real quick. I'm going to open up the student data again. So I'm not saying that this is actually something that you have an option of, but coming back to everything, going to insert pivot table, going to do that. And I'm just going to do this really quickly because I've done it a couple times already. Bring these down, change this to average, change this to count, click on OK, come up here. I'm going to grab the course name as opposed to the course. And this is something that I'm going to have to change in the future because there are a lot of other students that grab the wrong one. So I'm now going to look at this and say for you, because you're in this class, intro to stats and say stats for bio might be the two classes that you should be looking at. Uh, because just as an example, like I said earlier, I don't know if you were here or not, but stats for bio students is essentially the class that you're taking with me right here, right now. The other stats class that's up here, so intro to stats, that is the more typical intro to stats class that you might find at, say, a community college or something like that. Or this could even be, say, similar to AP stats that you would have if you're back in high school. So for a program like yours, I would actually think that those two would be better ideas for you. And just so we can see how quickly this can be done. When you get to and if when I'm done with this, if you want to like go back to sorry, if you want to go back to the video and actually pause it on some of these so that you can write down the numbers so you don't need to do everything over again. I'm totally fine with that. You've already shown me that you can do this, so I'm not gonna I'm gonna not gonna gonna try not to make this any harder than it needs to be. So I'm
Okay.
gonna drag down instructor and I'm gonna drag attempt and I'm gonna put that on top. So I'll make this a little bit bigger. So chemistry, I said one of them would be say intro to stats. See if I can make this a little bit bigger. So you can see starting here, coming down to here are all of the intro to stat professors. Looks like all of them except for this professor and this professor have taught at least 100 students. Some of them have taught a lot more. So I'm just looking in here and just really quickly, this professor's taught 143 students and essentially 91% of their students have passed. Cool. Looking at everyone else, again, based upon who's taught the most amount of students. So maybe this person that's right below them, Professor 46, 63% of their students have passed. And that would be in the Intro to Stat class. And I'll hold it here for a second. So again, if you want to grab this later on when you watch the video, you can see everything. I'm just gonna move that off the side. And then if
Um,
we scroll down to where we get to the stats for bio, you can see that even in this class, there aren't that many people that have taught it, but we do have these three and this one that have taught the class and taught a significant or taught over 100 students. So you might be interested in Professor number 2, and then say for this case, yeah, Professor number 133, something like that.
okay. So, can I share my screen again so you can see my pivot table?
Sure.
Just because I kind of struggle with that too. Hmm. You can't minus out.
Now it looks like you've got a Apple laptop.
Yes.
Okay. Uh, with the multiple file that I just uploaded, it
Yes.
might not work that well on your Apple because some of them don't like running macros.
Um,
You can work with another student in class, talk with them about it. The way that we were doing it the first day of class. If you want to like try to share your screen real quick, go for it. If you
um,
want to like use that VPN thing, uh, same way that you use SPSS, that will work. So if you go to say sheet number 2,
mm,
it's on the bottom,
yeah,
up and recovered. Okay. All right. So did you actually copy and paste just the physics or just the astronomy
yeah,
classes
I
or
just copy and pasted those
okay.
because that's what I was like under the impression that we were supposed to be doing. But then I just saw you did it and I was like, oh wow, much easier.
Yeah. So go back to sheet 1. Hopefully that's the original sheet. Uh,
Um,
sheet
this
1
one,
right there.
okay.
Yep. Nope. Yep. That one. So right there, click in the upper left-hand corner, right where it says A and 1. Yep. Click there. Down. Sorry. The corner right there. Yep. All right. Now go to insert. Yep. Pivot table. Yep. Yes. Okay. Click on that. Mhm. Uh, so now where you're looking at it, drag course name, not course, course name.
do I delete that? Delete.
Check the green box or hit the
Oh,
remove field. So
sorry.
course name, drag that down. Yep. Now scroll down in there. Now you can go to pass. Bring that down to the right. Yeah. Go ahead. Do that one more time with pass. Up right side, right side. Yep, right there. Nope,
Oh,
right
sorry.
there.
Oh, did I
Okay.
get that?
Yep, you've got it. You got them in the right spots. Now you need to change the values for those. So go back there. Yep, click on that.
Average.
Average. Yep, click OK. On the other one, click on there. Count. Yep, click OK. Now you can go to say instructor ID. Bring that down to where it says rows. Yep, right there. And then the last thing on there is attempt. Put that in the top row or on top of everything. Nope, where it says course name, like right there, let it go.
Good.
Yep. All right. So
Oh,
now
wow.
you've got pretty much everything you need. You can scroll down to intro to stats and then stats for bio or for bio. Look at the two professors that we were looking at in stats. Look at the two professors you were looking at in stats for bio. And then you can say, this professor is the best in intro to stats. This professor is the worst in intro to stats. This professor's best in stats for bio. This is the worst professor in stats for bio. And you have all their numbers and all their information right there.
Okay.
All that information is going to be on the left side. And then when I was talking about are those professors bad for all the classes they teach, or are they just bad for some of the classes they teach? So the way that you can do that is over on the right-hand side where the little area where it says rows.
Yes.
Yeah, down there. Move instructor ID up a slot. So click on it and drag it up. Yep. Like up one spot. You may have to have, all right, there you go. So
Oh,
stop. Okay. So I just said in stats for bio, Professor 133 was one that you might want to look at. So if you go back and you look at the data on the left-hand side, scroll down until you get to 133. So you can see 133 right there. For stats for bio, look at the percent of students that pass with him or her. And then look at the number of students that pass business calc. Do you want to take Professor 133 for business calc?
no. Yeah, no.
So, and this is the type of stuff that I was kind of talking about. So Professor 133 for intro to stat and biostat, not bad. The prob and stat, that's actually a calculus-based statistics class. So it's pretty much everything we've done in here, but a lot harder. And it's for engineers and scientists in general. But you can now see that they are based on what you're looking at there. You can now come back and say, Professor 133 is one of the better professors for teaching stats for biologists. However, he or she is really, really horrible at business calc.
Yeah.
And
Okay.
but that's basically everything that you need to do. So
Okay.
literally everything that you've just done in front of me in what, 5 seconds? That's
Yeah.
the whole thing.
Okay, my I do have a question because like I even was like had to ask my dentist. I'm like, did I do this right? And he could not help me
Yeah,
at all. I'm just wondering that in this.
yeah. And like I said, being able to use the pivot tables, being able to use Microsoft Excel to do things,
Oh,
this is something that you can actually get a job at. Uh, and if you can do things well with Microsoft Excel, it's easy to not only get that job, but say get a higher paying job. On Monday, I was talking with a couple of your classmates, and at one point, I was looking for a full-time job, and I just happened to type in Microsoft Excel, and there up popped a job opening for Excel analyst, 35 to $55 per hour to analyze data the way you're doing it right now in Microsoft Excel.
oh my goodness. That is
And
insane. That's good,
and
but crazy.
and just to put this in perspective, 35 dollars per hour, assuming you work it as a full-time job, is going to be about 70 grand a year. So $55 per hour is going to be about 110 grand per year. For
Yeah,
110 grand per year, are you willing to learn Microsoft Excel?
definitely. I wish I would have learned it more in high school, but I feel like our school like pushed Google, but irrelevant. Can you still see my Google Doc?
I can't see your Google Doc. All I can see right now is Excel.
Okay, bear with me. Because I just wanted to show you my first part because I was confused on it because I was looking at the pass and then pass with an A, and then that kind
That's
of
that's completely fine.
that
Um,
confused me if I was supposed to like what was my actual number? Did I do pass with an A,
well,
including I'll show you. Hold on, let me.
I know I saw what you were doing. Uh, in the instructions, it was what? Uh, dealer's choice.
Oh,
What do
okay.
you want to look at? What are you interested in? So, like we were talking about, like beginning of class, uh, the quiz versus the exam. With the quiz, there's like the 25% chance you can get an A on it. Whereas with the exam, there's literally no chance you're going to get an A on it. But when you take the exam, we can pretty much guarantee you're going to pass. You're just not going to get an A.
Okay.
For you, is passing the class the important thing for you? Or as Audrey was saying, is getting an A more important to you? So again, that's part of the like the dealer's choice. What do you want to do? What's interesting to you? And I put both of them on there because it's honestly really, really easy to do.
Okay.
If you want to do both of those, if you want to look at pass and pass with an A, you have to go to the field name again, grab the pass with an A, drop that down. So pass with an A, drop that down into values. Yep, should so sum of pass with an A, change that to average pass with an A.
Oh no, how do I get this back? Because this kept happening to me all the time when I was trying to do
Click
this.
on any of the data. On the left side, click on any of the data.
Oh my gosh. You know how many times I had to like read-down this whole sheet because of that? I'm not even kidding you. I was like getting so mad. Okay. Uh,
So average, go ahead and click on OK. To make it a little bit easier, maybe move average pass with an A.
oh,
Uh, so now you've got pass and then pass with an A. Should be able to move it up one more spot. But however you want to do it, that's fine.
oh
As long
man.
as you understand what's going on. So if you, so there you go. Column B, probability you're going to pass. Column C, probability you're going to pass with an A, and the number of students uh, that actually were in the class and passed. So that's what you have right there is totally fine. Just make sure you can keep everything straight. And I am looking at Professor 131 right now, okay? So up a little bit. The class that says none. And I still have no idea what that class is, but you can see that 131. So right, yep,
Yeah.
right there. Uh, so you can see that 77% of that professor's students pass the class, but like 58% of them pass with an A.
Yeah. I want to take that
So
class.
yeah,
um,
so so that's where all this stuff is coming in. And again, uh, so like say the difference between you and say Audrey. Audrey needs an A. You just want to pass. What's important to you? It's passing the freaking class, so you never have to think about this crap ever again, right? What's
well, who
important for
knows?
her?
Maybe I'll work for
She needs,
Microsoft.
yeah,
Yeah, no, I hear you.
but what does Audrey need? Her most important thing is getting A's so she can get into the doctor of physical therapy and all that sort of stuff. So
Yeah.
again, it's what's important to you. Um, so on this assignment here, what's going on? It's what information is useful to you.
Yes.
Uh, Assignment number two, it's calculate all these things based on what I told you. Well, what's the journal assignment? You go out and you find a medical condition you are interested in. Why you're interested in it, I don't care. Couldn't care less. You figure out what are the chances of getting that particular disease or having that particular medical condition. How good are the screening tests for that? And then you go through and you calculate, um, uh, like how accurate is a positive test? How accurate is a negative test? Uh, for whatever it is that you're dealing with. If it hap I think we talked about one of my students who had her baby taken out of her arms uh, after giving birth because she tested positive for drugs, but it was a
Mhm.
screening test. Uh, what's the accuracy of a positive screening test? And there is actually, and I think I mentioned it in the video. If not, I'm mentioning it now. You can actually find a couple different lawyers and a couple different lawsuits where literally the sheriff's department or the city police department was sued and lost cases where someone was arrested on suspicion of having drugs on them based on a roadside drug test, and it was sugar.
What?
That
That's-
actually factually did happen.
Oh my
So,
goodness.
so if that is so, uh, first class that I taught, or first big class that I taught, I covered that, and literally one of my students came back several years later and said, "Thank you for test or showing us that." He did the calculations for his friend's parole officer to keep his friend out of jail, pending a more thorough, more accurate drug test.
Mm.
So with
Okay.
drug tests, if that's what you're interested, and I'm not saying you are, but if you're interested in drug tests and say the legal ramifications of getting the wrong answer there, uh, that would be really great. If you, if you, and I'm not saying that this is you, but let's say, you know that in your family, a certain type of cancer, happens to occur. If you want to deal with that type of cancer because it's personal to you, by all means do it. You don't need to tell me why you chose it. If you do, that's on you.
Mm. I don't Oh, what will I choose? That is very interesting. I'll have to think on that one, but that's not due for a few more weeks, right? Like until the end of middle of September, like the 27th or something, or
Whatever day I put it on, homework 2 is due next week.
yes.
That journal assignment is like 2 weeks, 3 weeks out.
Okay, so
So everyone's got time to work on that.
so with this one, if I like redo all my data or type my data out, if I what do we have until Friday then to resubmit or
Yeah,
submit that? Okay, perfect. Thank you.
yeah, no
And
problem
then
there.
I guess since I have you on, I don't know if I can ask this now, but I just had a quick question in regards to next week's assignment. Let me share my screen here with this. Share. Okay. So we're using the calculator that we downloaded
Mhm.
today, and we
You- that you downloaded last week.
yes, last week. No, I did download it, but I didn't know what it was last week. I'm gonna be honest with you. So what
Yeah,
do we use the the binomial bi
conditional probability.
traditional probability? Okay, let me read.
So do you have that Excel file on your computer already?
Yes, let's open
Go ahead
recent.
and open it up real quick. All right. So looking at what you have on there, for the first problem, I said the false positive and false negative is 5%. Can you go back to the homework assignment real quick? So we can see, make sure I've got the right numbers. I think I said the probability of an event is 2%.
How do I share both screens at once? Like, how do I, is that
No,
an
this is
option?
fine.
Okay,
So just for the first one, 5%, 5%, 2%.
5%, 5%.
Yeah, so go back to the Excel sheet real quick. So you've got 5%, 5%. Do you see where it says probability of event?
Oh,
Nope,
I'm sorry. Yes. Okay.
undo that.
Yes.
Undo, undo, undo.
Undo, undo. Got it.
So uh, row number 9, probability of event, and then there's 9, so down 2. One more, yep, right there. So type in 0.02. 02. Enter. You've got the answers for problem number 1 right there. That's
Oh
how
my
easy it is.
goodness. Okay, I was like so confused. Okay, thank you. And then, so that's how we answer the remaining of them. But
Mhm.
wait,
So you have to like false positive, false negative, probability of event. Uh, the example problems in the video that I did on that, I looked at a lot of times we consider a medical test or medical screening test to be 95% accurate. If that's all the information you have to assume 5% false positive, 5% false negative, and run with that.
okay,
Um,
like the
but if I'm
last
looking at
one.
like say Cologuard, uh, it's 78% accurate, so you have to change it to like uh 22% false positive, 22% false negative. There are a bunch of calculations you can do in there. Uh,
Okay.
but it's all putting all the numbers that you have in those 3 cells, D7, D8, and D9. Those are the only things you touch here.
Oh wow. Okay. And for the last one, do we like and it was kind of alluding to your student that you were just telling me about. Do we just assume that it is the 552?
Uh, go ahead and check out what the question is actually asking.
Sure.
And you can see right there, it says accuracy of a positive test is about 28%. So on that one, I'm asking you to find what is the accuracy of a typical drug test. Since you know it's a urine test, if you want to say go to Google, you can find that. What legal non-prescription medications can cause a false positive? So again, we have in one of the videos, I actually looked up some of those things. So you can look them up.
Spell that wrong.
Ibuprofen.
Yeah.
Well, ibuprofen is one of them. But there are, depending on which website you look at, I actually found like a dozen different things that I actually have in my cupboards at home that could produce a false positive test. I also found uh, that there are certain foods, especially for people from the Middle East or India, that particular area, like certain spices that are common in their food that can also cause a false positive. There's also, if you ever eat poppy seed bagels, so those little black seeds,
Mhm.
if you eat a bunch of those and then you go take a drug test, there's a chance you can test positive for morphine or heroin. Why is that? If we're going to make heroin, what is it made from? It's made from the poppy plant. What else is made from the poppy plant? Poppy seeds.
Oh, wow. Yeah. Crazy.
Uh,
Okay.
the difference is with the if you're if you're gonna go out and you're gonna say, I don't know, let's say you want to be the next drug kingpin of Michigan or something like that, you start planting poppy seeds, you have to have like say acres and acres of poppy seeds in order to get say a few kilograms of heroin or something like that. So it is very, very noticeable. It's not like say if you grow pot at home, you can have two plants of it, and you can probably get enough of a harvest off of those plants to last you for personal consumption for a while. You can also hide them because it's only a pot or two. Uh, but if you're going to try to do that with, say, poppy seeds, you're going to have like 60 or 70 of these things. Where do you hide all of those? Not going to work too well.
Hmm.
But anyway, so do you have any other questions?
Not that I can think of at this moment, but I really appreciate you staying after for me. I have Zooms like every single day. I'm not even kidding you. I'm taking 19 credits right now, and it's like I have like 10 things due this week, and it's like, and I work full time, but that's okay. That's my problem. I signed up for it. But I I really appreciate the clarification on this. Yes.
No problem. So I will torture you next week. See you later.
I just muted me. Enjoy your weekend. Thank you so much. Bye.